Hello Internet, my name is Quinn and this is Blondihacks. Today we are going to finish the cylinders on my Pennsylvania A3 switcher locomotive. These are incredibly intricate and detailed parts. I think I've got probably 30 or 40 hours into them, maybe even more at this point, but a lot of really cool operations, so let's go. Previously on Blondihacks. If you watched the previous video in this series, you know that I machined this face of this casting, and it came up 20 thousandths short because the casting did not have enough material in that area. This was a bit of a bummer, and I spent some time thinking about what to do about it. I considered scrapping the parts and starting over with bar stock, but that would set me back almost a week. I've got about 25 hours into these castings at this point. I also considered some sort of repair. I could potentially silver solder some extra material onto the side of the casting and then machine it back down. Or if I had the skill and equipment to do so, a person could theoretically apply some bronze brazing rod to the area. None of those I think are going to make a very good looking repair, however, and the area in question is very visible. It's the side of the steam chest right on the side of the locomotive where everybody's looking, and any kind of repair I think is going to be visible. And this is also cast material, and silver soldering and brazing cast metals is different than bar stock metals. It's not something I have a lot of experience with, so I didn't like my odds of success on that. That all led me to consider what are the actual consequences of that one dimension being 20 thousandths under. I mean, 20 thousandths is not a lot. It's not great. We do try to do better than that around here, but it's not terrible. So I decided to model up the mating part, the steam chest body, in CAD and see what the effect would be of that steam chest base being undersized. Shown here in yellow is the steam chest with 20 thousandths shaved off one side of it to match my cylinders, and in pink is the steam chest as designed. And you can see as I go back and forth between them, the difference between them is barely detectable. Like if it wasn't going back and forth in CAD like this, you'd never be able to see it. There's still plenty of meat around those bolt holes, and the difference is certainly not enough that you can tell by looking at it in person that anything is undersized. Furthermore, by removing the material just from the outside of one edge, I can preserve the references of the steam chest. Here's what I mean by that. I made myself new drawings of my modified steam chest, and all of the dimensions on this steam chest are referenced from the center line. And I've preserved that center line as referenced from the insides of the steam chest. So the only thing that's changed is the distance from the outside of one side of the steam chest to that standard center line. So as long as I'm careful to not take a center line reference off the outside of the part as I machine it, then nothing else on the steam chest has changed. The bolt pattern is the same, the interior volume is the same, the performance of the locomotive won't be affected. Nothing else has changed as long as I just make that modification on one side. Once I saw this in CAD, I realized this was definitely the way to go. This error is just not big enough to throw away a week of work and start over. So I'm going to proceed with these castings and we're going to make them work. And hey, if you see this locomotive at a model engineering show someday, you can come up to me and say, "Hey, beautiful work on that, Quinn. Steam chests look a little narrow though, aren't they?" I might chuckle and give you a sticker, or I might punch you in the pancreas. I make no promises either way. The next step then is to mill out the steam ports. These are blind slots that go in the top, and they're going to have the steam passages connect to them. So in the center, we have the main steam exhaust port. It's a fairly large port. And then on either side of this, we've got two skinny ports, which are the transfer ports. They alternate between being intake and exhaust, depending on where the cylinder is in its cycle. The cylinder ends alternate being power strokes. So the end that is currently the power stroke uses the transfer port as an intake, and the opposite side is using it as an exhaust. Weirdly, there was a dimension missing on the drawings here. The steam port depth was not given anywhere. And because those drawings are not perfect, there's a few little errors like that here and there. With normal engineering prints in a situation like this, you can take a measurement off of the drawing directly. It's not ideal. You certainly try to avoid doing that, and you try to deduce the measurement from other dimensions, but if you can't, then that is a last resort. However, you can't really do that on Kozo's drawings. They are drawn to scale. He is careful about that. They're always 1/2 scale, pretty much. However, they're printed in a book, and the book printing process has scaled everything by an additional arbitrary strange amount of something like 3%. So it's really not reliable, and because the drawings are so small, the lines are quite thick for the size of the drawings. So measuring off the drawing, really not an option, and sometimes cases like this, you just have to make an educated guess. Now, in this case, the depth of them isn't all that critical. All that the depth is doing is giving us a larger target to hit when we go to drill out the mating steam passages, as you'll see. However, with those done, I can now drill out the bolt pattern that goes around the top. This is to bolt down the steam chest. Once again, being careful to use the correct reference center line of the steam chest, which is not the same as the center line from outside to outside on my now modified cylinders. Those get drilled and tapped, of course. With blind holes on this project, I'm always bottom tapping them as well. I've learned the hard way with Kozo's drawings that he does not give you a single extra thread anywhere on depth for the fasteners. So if something is a blind hole, always bottom tap them, even though he doesn't actually say to do that. Using the collet block now, I can index 90 degrees to get back to the manifold face. This is the face that the steam manifold attaches to bring the steam in and out of the cylinder. And I've got a series of holes to drill here as well. There's a 6-bolt pattern that mounts the cylinder to the frame of the locomotive and also mounts the steam manifold to the inside of this face to pipe the steam in. And then there's the start of 2 steam channels there. The small one is for the high pressure intake and the large one is for the lower pressure exhaust. I've finally done all the features that require indexing between the 2 surfaces now, so this part can come off of the mandrel and I can bring in the other part and do all the same steps to it that you saw starting with the beginning of the previous video in this series. I kept that one casting on this mandrel that entire time so that I never lost my accurate 90-degree indexing of all of these features. And that is the 2 cylinders brought to this point. Next, I'm going to use this mandrel as kind of a rotary fixture of sorts because I'm going to machine down most of the extra material around the round portion of the barrel. It's not clear to me if the casting maker intended this area to be left cast, but it's certainly over dimension if so, and it's also extremely not round. As you can see, this round area, this casting is very, very lumpy, and it looks like the patterns that they're using are quite worn out. No biggie though, I just use this fixture to rotate around and take a couple of rough cuts down the length of this barrel to bring it close to final dimension. The final desired dimension is the same as the outer edges of the cylinder that we turned on the lathe. So we'll be bringing it down later, but for now we're going to rough it into this point because it'll make subsequent setups a little bit easier, and we're all set up in the middle here with the mandrel anyway. As you can see, this leaves us with kind of a low polygon approximation of this curve. It's like a 90s graphics card. We'll call this the Voodoo 2 finish, and we're going to be refining this later with a series of additional steps. Then I'll bring in the other casting and get it to this same point. This is the last use for this mandrel setup in the mill like this, so I'm going to do this now while we're here. Looking good in all of its Garrod shaded glory. Now, the next thing I'm going to do are the steam passages, and these are the most difficult features on the entire parts. These are the internal plumbing of the cylinders. This is nerve-wracking stuff. However, I've got a really fun fixture to do this with. This is my angle adjustable table. And don't ask me where to buy this. I don't know. This was a donation to the channel by a viewer at the Barzy Bash a few years ago, but I absolutely love this thing. All I can tell you about it is that it says TII on it and it's made in Japan. You can probably still buy something similar. I don't know, but I love any excuse to use it. It's going to be just the thing to allow me to set up these cylinders with the collet block so I can still index them, but in addition to the 90-degree indexing, I can now add in an angle offset from that 90. So this is going to allow me to drill all the different steam channels at all the different fussy little angles that are required. And yes, the angle markings are on the back in this setup because it was necessary. This table doesn't angle the same amount in both directions. Stop typing your comments. I'm going to do the main exhaust passage first because it's the easiest. This is a straight shot at a weird angle from the steam manifold through to the port face. I start by milling myself a flat spot, and then I bring in the drill prepared to drill this through. But I got to make sure this angle is exactly right because it has to land exactly in that main steam port in the center of the port face and not break into the cylinder in the middle if I get that angle wrong, and of course it has to start in the correct place. So I'm lining this up by eye with the drill in front of the part. Now Kozo gives you the angle for this in the drawings. However, I set up his angle and it didn't look right, so I actually kind of cheated it a little bit shallower because to my eye it looked like it was going to come up short on that port face. So, heart fully planted in throat, and here we go, drilling the first of the steam passages. This is always the most nerve-wracking part of any steam engine build, because if these go wrong, the part is scrap. Look at that, right through that port, like a boss. That was a big relief. That really couldn't have gone much better. Metric horns of victory, well earned on that one. And the nice thing is this setup repeats, so I can swap in the other cylinder, get it aligned 90 degrees to the table, and all my other aspects of this setup, the angle of the table and the Y position and so on, are all going to be the same. I drilled out the other one the same way. Let me show you how these channels work because they're pretty cool. So this first one is an angled pipe, if you will, that goes from the steam manifold into the center of the main steam port there. Now, as you can see, I actually almost missed with this. Instead of coming up through the bottom center of the steam port, I came in kind of on the corner of the port. And in fact, the one on the right is the first one I did, and it was even closer. You can see it almost broke through into the port face, which would have been a disaster. So I actually tightened up the angle a little bit after my first one. I should not have chickened out, and I should have just used Kozo's angle as specified, because having drilled them now, I see that his angle would have been actually just about right. So for the rest of them, I used the angle in the drawing. All right, but that was the easy one, believe it or not. This next one is the main steam intake passage, the high pressure intake. And this is actually two pipes inside the casting that need to meet in the middle at different angles. Super fun. If that wasn't fun enough, the starting point for one of those two passages is not dimensioned on the drawing. Kozo marks it, but there's no dimensions on it at all. So here we are with that again. The Y position of it can be deduced from the drawing because it has to line up with the mating passage, which is dimensioned. However, this is an angled hole that has to start somewhere on this port face and go through at a specific angle that he does give you in the drawing and somehow magically meet up with the passage in the middle going the other way. The good news is that, like those steam ports that were also missing a dimension, the exact X position of this steam channel doesn't matter that much. Like, you have a pretty generous target to hit with that other steam passage. So as long as we are sure to get the angle correct and we miss cutting into the bore in the center, then we'll be okay. So I deduced again from the drawing about where Kozo intends this port to be, and I started by center drilling that position with the port face square, because this is the position in which I can measure the position of that hole with the edge finder. However, the hole actually has to be drilled at an angle, and I can't measure the position of that hole once the face is at an angle. So I do it now, mark the position with a center drill, then I can rotate the part over to an angle, use my pointer to locate that feature once again on the angled face, zero my DRO there, and now I can drill the passage. Because I'm at an angle, of course, I have to start with an end mill and make a flat spot face this position. Then I center drill the center of that flat spot to make sure that the drill is going to go on that position. And now I'm ready to drill. However, I don't know exactly how deep to go. The depth of this is again not indicated in the drawing. So I'm once again eyeballing it, just putting a square on the port face and trying to get down low and reduce parallax and try to eyeball where that drill is going to need to go. Again, this doesn't have to be perfect as long as I don't go too deep and as long as I make sure that the drill isn't going to cut into the cylinder bore, then it's going to be okay, in theory. But there's nothing to it but to do it. Let's see what happens. I had decided how deep I was going to go with this thing, and I'll go down that deep, and then we'll have to flip it around and do the mating passage and see if they connect. I didn't feel it break in anywhere, so that hole went down there somewhere. It's somewhere inside that casting, so it's probably not fatal, because if it had broken into the cylinder or something, I would know. I'd be seeing steel chips come up off of that mandrel, which, well, this video wouldn't have come out because I'd have been having a very bad day. However, that went okay, I think, so now I can index the part around 90 degrees, get squared up on the table, and now drill the mating passage, which is square to the steam manifold face. And if I did my job right, this should go down not very far, frankly, and I should feel it break into the mating passage. And I did. You can see the chips coming out of the bottom port there. It looks like that worked. Metric horns of victory number 2. So far, so good. Then I do the other cylinder the same way, of course. Now here you can see how those two steam passages have connected and the light can get through there. But now for the transfer passages. These are the really hard ones. I have to set the casting up on end for this, and I'm squaring it up on Z to one of my T-slots. This doesn't have to be perfect. The Z orientation of the part is actually not that critical for getting these passages to line up. Then I set my angle to what Kozo says in the drawing it should be. I've learned to trust him on this point. Now these passages go from the very corners of the cylinders down to those skinny little steam ports around the sides of the port face. So once again, I have to start with an end mill to spot face an area. However, I don't just have a single round spot here. I have to make an oblong flat spot because these transfer passages are doubled up. There's 2 drilled holes side by side because we need a little more volume than we would get from a single drill that would fit in this area. I know the angle is bad there, but trust me, there's a flat spot down below the ridge line here of that area. And now at one end of that little flat spot, I can center drill for the first of the drills. So it's like 2 parallel pipes that basically make up enough volume that would be required for all of the steam to get through here. So the volume is the same as the single large hole in the center of the port face. This is a common technique in model engineering because you can't mill a slot all the way down through the middle of the casting like that. It would be an impossible feature to machine. So instead we drill 2 side-by-side holes to get the same physical effect. This one was very nerve-wracking though because this is a very, very small target to hit. Those steam ports are only 78 thousandths wide. I cannot adequately describe the relief I felt when that broke through perfectly into that tiny little steam port. And I just had to do that 7 more times. Here's a look at those transfer passages. You can see how they come out right on the corner of the bore, partially into the cylinder head area and partially in the bore. And that's so that when the cylinder is at top or bottom dead center, it's never blocking that passage. The steam can always sneak into the tiny space above the cylinder. So that's why you have to start this passage right on that corner. And no, they're not supposed to be centered. One of them is centered on the bore, but one of them is off to the side because the center line of the steam chest is different than the center line of the bore. Just to add a little bit of fun extra difficulty to this feature. That actually took about a day and a half because I was just being so careful to check and triple check and quadruple check everything before drilling those holes. But it's done. I can exhale, and let's get the mandrel set up in the lathe because we're going to finish those low poly round features now. I'm going to do this on the lathe with a shaping operation, very similar to how you can cut keyways on a lathe or splines or other similar features. Got a grooving tool set up sideways in my tool post, on center of course, and we're going to use this to manually shape this guy with the carriage. This works just fine as long as you take light cuts. In brass, you can go as heavy as 5 thousandths. In steel, I wouldn't go any deeper than about 2 thousandths, or else you're putting an awful lot of strain on your carriage hand wheel. But otherwise, this works better than you might think. Because a lot of people are probably going to say it, why am I not using the rotary table for this? There's really no practical way to do this on a rotary table. The setup to get this casting mounted on the face of the table concentrically would be incredibly complex and difficult, and frankly it would take longer to set that up than it took to just do this on the lathe. Once you get a rhythm going with this, it really doesn't take long. A full pass of this only took a few minutes, and I did 2 passes per cylinder. Just knocking the high spots off the previous pass as you go around each time. It's actually also extremely satisfying. The other advantage is that with a shaping operation, we can get in really close to that corner where it meets the steam chest base and make a really nice transition. The first pass brought me to like an ATI finish, and then the second pass brought me to a solid G-force finish. All that's left then is to do a little bit of anti-aliasing to blend all of that together into one clean, smooth surface. And you'll never know how that was done. At least that's the hope. Of course, some quality time with needle filing was required, as with any model engineering part, just to make sure that there's no tool marks left in areas where the Scotch-Brite wheel couldn't get, and make sure there's no burrs and make the transitions to the steam chest as nice and as clean as possible. The more time you spend with files, the better the final part will look. That's pretty much a rule of model engineering. I also rounded all the corners to a nice 3/64 to match the drawings. And now we're ready for the final feature on these cylinders, which are the drain cocks. So back over to the mill, squared up, to drill and tap some little holes on the undersides of the cylinders. The drain cocks are what allow you to drain the water out of the cylinders when the locomotive is sitting still or when it just starts moving after having been sitting for a while. The cylinders have cooled down, and any steam that goes into them is likely to condense into water. So you have to be able to open the drains in that situation to let that water out. Because if the piston hits that water, it's going to hydrolock and it's going to break something. It'll crack the rings, it'll bend the piston rod, crack the heads, something terrible will happen. So when you see locomotives sitting in the station, steam billowing out of everywhere, What you're actually seeing is the drain cocks being open. When the locomotive is underway and under power and everything's running efficiently, you won't see any steam leaking out anywhere. Only the drain cocks do that. There are the final cylinders. These things were an enormous amount of work and pretty high drama. There was some lost sleep over these, but overall I'm really, really happy with how they came out. I think we overcame a lot of challenges. Enough talk, let's get them on the chassis and see how they look. Those get bolted on like so, and then the steam manifold bolts through to the backs of them through the big holes in the frame. And there they are, 2 cylinders mounted to the chassis, ready to make tractive effort any day now. You can practically hear the choo-chin. They are going to get powder coated, of course, to match everything else. And we got valves and steam chests and pistons and all kinds of other stuff to make before we can get back to the valve gear. But I'm feeling good about the progress. I hope you are too. Thank you so much for watching. Thanks to all of my patrons who make this content happen every single time. And I will see you next time.